Okay, geographers, going to go over your third lab, this navigation one, with you. And just so you know from the beginning, this is one that drives most students crazy because I think really the reason why so many students find it difficult is it requires you to think. Um, yeah, that's really all it is to it. Just open your brains now, be prepared, be ready to just dive into this. Okay? And what we're going to be getting into is how to find one's latitude and longitude. So that stuff you studied last time, learned about, found where you were, all that real basic stuff. Now what we're going to do is figure out, say you're lost somewhere in the world, somewhere on the planet, you need to figure out where you are. Well, we're going to show you how to do that with this lab here. And that's the idea. So we're not so much interested in, pointing to things on a map, but we're kind of going the other way where, I don't know where I am. I got to figure out where on this map should I be. You dig? Hopefully you dig. All right, that's the idea. And again, as always, read through this stuff in here just to get a sense of what we're getting into. Look for possible, answers to questions you have or key information or things like that. Read slowly. All right. So through here, on the first page, you have one question, and it's about the subsolar point. What I'm going to do for here is just let you guys figure that out. Chapter 3, I think, of your book will get into it. My lecture in the lecture class about the sun and the earth and seasons and all that stuff, I'm going to talk about that there. And that'll hopefully be up on Canvas in the next few days or so. I'm shooting for this week with that one. So you'll have that to watch. You'll see that, but you can just Google it. You can figure it out. You'll get a pretty good idea of what it is. But use the textbook to help you, make sure you know what it is you're looking for here. So I'm going to leave you guys to that right there. And this is getting into this whole analemma concept, which is, let me jump forward, which is this thing. This kind of funky figure eight, lumpy looking thing. That's our analemma, and it's a very useful, tool. It's a diagram. It's showing this subsolar point and where it is throughout the year. And the way we use it, if I go back here, so on this preceding page here, use the analemma to find the subsolar point for the dates listed below. It's real straightforward. Like October 15th, this first one, what you need to do is look around your figure eight, find October, and pay attention to the direction at which it's moving, right? So here's September, August is up here, so we're going this way throughout the year. So here's October, and it was 15th, which is right here. And you want to do the best you can. Not all of these fit perfectly on the line, but if we look over this way to the left, we see 8 degrees. And that means, and it's not perfect, but just around to the nearest degree or half degree. Yeah, if it looks like it's perfectly in the middle, use that. Otherwise, like in this case, we're just going to go to 8 degrees. It'll work for what we're doing here. So 8 degrees, and it's also important to be aware, it's 8 degrees south. Okay, and if you see here the 0, that's the equator going this way. Here's our northern hemisphere. Down here, it's our southern hemisphere. So for October 15th, the subsolar point is at 8 degrees south. And that's what you would answer there. Okay, and then just move on. This question 8, what is special about the dates for the questions 4 through 7? Try to figure it out. See if you can get it. And these dates, kind of funky. They change by a day or two each year, but each year something significant from a seasons and our relationship with the sun standpoint happens on June 22nd, give or take a day or two, or December 22nd, give or take a day or two, and so on. So work through that. And again, if you're still stuck and you can't figure this stuff out, you can wait for that lecture to be recorded and put up on the Earth and Sun and seasons and all that stuff. All right, but that's really, for all we're doing in here, all you need to know about the analemma and how to read it. Okay, days of the year here, and then this area where the subsolar point is located. Okay, that's the concept there. All right, now as we move through, we're going to start with figuring out latitude. Okay, and I do want to go over this with you guys just to make sure you know exactly what it is you need to do. And I'll get into longitude too, and we'll continue through here. But this one, because we're doing it in kind of maybe a weird way, since we can't actually go out and take readings, of the sun with a sextant and all that, we've got these little images here, these little diagram things down here, and I'm going to show you how you should use it. All right, but it's the idea. We're going to pretend that we have a sextant, and we're looking out, toward the horizon, and we're also looking at the sun up at the sky at its highest point, and we're measuring this angle. Okay, so the sun's altitude on this day at solar noon in this location would be 43 degrees based on this. Okay, and so you're going to need to be able to measure it. Okay, once we get that, we can calculate our latitude using this 90 minus the solar angle at midday plus or minus the analemma correction for that day. Okay, and we'll walk through this first one just to make sure it's clear. Also, if you're currently in that lecture class and you've listened to me with the geodesy lecture, and I get into latitude and longitude, and I explain how in the lecture class on your first exam you're going to have to calculate latitude and longitude. I stress in there that it's going to be different in the lab compared to the lecture. Right? So I talk about one thing in the lecture class, and we get into using Polaris or the Southern Cross, how we can do that. We're going to use in here. We're going to use the sun, the analemma. It's a different system. Okay, but keep that in mind as you're working through this, as well as when you're studying for that first exam in the lecture class. All right, make sure you separate these things. Keep them sorted out. All right, that's the idea. So with this, we're going to walk through this, and we're going to assume, see, and again, this is why reading all this stuff is key. For figure 3.3 on the next page, we'll see it, shows the location of a person at midday on April 20th. Okay, so keep that in mind, and we've got it down here as well, right? April 20th. And so we have our sextant, the horizon, the sun, and what you need to do is have your protractor, this 180-degree protractor, the half circle thing. With this, you're going to use this to actually get that angle, right? And I know, just based on experience, for a lot of you guys, you haven't used one of these things for years, or like introduced them in middle school and maybe high school, and then we don't use them again for quite some time. Just a little refresher here. Your protractor, they'll look kind of different, but it's the same general idea. This one has a little circle hole thing in here. I want to line that up with this X that I made. So whatever kind of protractor you have, and whatever kind of sighting, centering location thing right here, it might be a hole, might be like some crosshairs or something like that. Line it up with the X. Okay, I don't know if you can see that on this video, but that's why I put this X here. So it's something consistent to set it through, right? And then you also want to line it up. So I can turn it anywhere along the X. I want to line it up so it's even with the horizon. Okay, you follow that? And so do that as best you can. Like, take your time with this right here, right? And I'm just I don't know, looks fine. I'm kind of at this weird angle with this camera. We'll just assume this looks pretty good right here. And I'm going to find that midpoint of the sun, like right around there. Okay, and if you read, line that up again, I'm going to say that's 55 degrees right there. Okay, and I can also, well, yeah, I'm trying to think of the best way to show you guys without being there in class, but it's the idea that as I'm looking up this way, I'm going from 0, right, up, counting up, and the middle of the sun, which is what you should be, aiming for right here, looks like it's, and I keep messing this up, but it looks like it's 55 degrees right there. So, right, 50, 60, halfway between that longer line, that'd be 55. That's where I'm getting that number from, right? You'll also have on these things, the numbers go the other way, right? Which would be useful if I had the sun, over here. Just a matter of, perspective right here. But make sure your angle is going to be 90 degrees or less, right? So for me to write down, 125, that actually wouldn't make any sense. And as we, got through, hopefully it would become clear that, oh no, that can't possibly be the right answer. So your number here is going to be less than 90. Right? Or 90 if it's at the subsolar point. There's a little hint at what that term means. Okay, so if we say it's 55, I'm going to do that right here. Okay, so that's my solar angle. Okay, then we're just going to move down, subtract the solar angle from 90. So that's 90 minus 55. Gives us 35, right? Now, and that's just simple subtraction there. That's all we're working toward here. Now, we're going to go back and find this analemma correction. Okay, so April 20th. What we need to do is cruise around. Here's April. This would be the 20th of April right here. Okay, so we need to find that date. Look over again, okay, and so it's 11 degrees north, all right, so we're going to put 11 degrees, and it's in the northern hemisphere. We can leave that there. It's kind of useful, not totally important for everything we're doing right here, but with this formula, if we go back here now, where's that? It's 90 minus the solar angle, so minus 55, plus or minus that analemma correction. All right? So we're going to get two answers, effectively. So it's 35 plus 11, should be 46, or 35 minus 11, should be 24. All right, and what we do, what's explained here in 13, generally one is in the northern hemisphere and the other is in the southern hemisphere, meaning these two different numbers, right? So if I, take this, whatever angle I have here, I also need to be aware of in which hemisphere I'm dealing with right here, right? So the larger of the two possible numbers will be located in the hemisphere which is experiencing longer days. That is experiencing spring or summer, okay? So let's assume, and therefore, too, that means the smaller would be in the hemisphere that's experiencing the shorter days. You follow? So let's assume that in figure 3.3 is somewhere in the northern hemisphere, okay? So it's April, meaning what season? Spring. So that's going to be longer days, so it would be that larger number, right? 46 degrees north would be my location. That would be my latitude for that. Okay, so all you're going to be doing, and I'll show you here, these next ones, you just have, little images here. Northern Hemisphere, May 20th. Northern Hemisphere, February 1st. Okay, and you've got a few of these to work through. Now do keep in mind, and then Southern Hemisphere and Southern Hemisphere, do keep in mind, because we haven't gotten into this in the lecture class, but the hemispheres experience opposite seasons, Okay, so when it's summer for us up here in the northern hemisphere, it's winter for folks in the southern hemisphere, and vice versa. Okay, keep that in mind. We'll get into why that is again with this lecture that I keep hinting at how oh, it's going to be wonderful about the sun and seasons and all that. So we'll get into the why later, but just keep that in mind. Okay, seasons are opposite in the northern hemisphere and southern hemisphere. All right, so work through that stuff. Then with longitude, this gets into time. And I discussed this in, again, the lecture class and getting into how to calculate one's longitude, like if you're lost at sea or whatever. That's exactly what you're going to be doing here. Now, in here, it works effectively the same way as I get into in the class. We're going to take it a little deeper and use some, trickier numbers, things that aren't necessarily nice around, it's solar noon where I'm at here, and it's 3 o'clock in Greenwich and all that. We're gonna take it a little more. It's gonna be more realistic, I guess. We want to think of it that way. So what I want you to do, since I've discussed it, some of you guys have hopefully by this point listened to, and if not, this will encourage you to listen to that geodesy lecture. But you can listen to how longitude works there, but also just read through here because we try to take you through, just step by step and build on stuff. And if one question, seems kind of like too simple, maybe in some cases, read the next few questions and you'll see that we're actually, we're building, we're stepping, one little bit at a time to get to that bigger answer, right? So read through this stuff. But like here, 18, if we assume the Earth is a perfect sphere, after, of course, you're only reading this after you've read all this other stuff, represents how many degrees, right? So how many degrees are in a perfect sphere? How long does it take for the sun to return to the same point each day, right? That is how many hours pass between solar noon on Tuesday, solar noon on Wednesday. So, how long is a day, right? And then using these previous two answers, calculate how many degrees the sun travels through the sky per hour. Be sure to show your work. And you can also, I talk about this in that, that geodesy lecture as well. And if any of you guys, I don't even know, I haven't checked yet. I know a lot of you are in the lecture class with me. If any of you are not, I know, in fact, I know one or two of you have mentioned I'll be sending some emails out, but I'll link, in fact, what I'll just do, I'll just post this in the announcements. I'll link you to my YouTube page where you can access those lectures. Where I've been putting with all this COVID stuff, I've been starting to just stockpile lectures for classes there, so you can find that. There's a physical geography, a little, what do they call, like a playlist or whatever. You'll be able to see that. You can access that just so you actually get it. If you don't remember it from the last time you took the class, right? So I'll make sure to put that link in Canvas. So look for that. All right, so you can read through here. Now we're going to get into time zones in this section, and we've also placed, to make it a little easier for you, this world time zone map in here. And the way to read it, like here we are in California, we're in Pacific time, Pacific Standard Time or Pacific Daylight Time, all right, depending on whether it's daylight saving or not during the year. But what that means, this whole time zone idea, is that our watches are set to what the sun is doing at this controlling or standard meridian. Okay, so you can see up here, standard meridian, meaning that for our watches and our cell phones and all this stuff, it's all set to what the sun is doing at 120 degrees west. Okay, so noon on our watches corresponds with the sun being directly overhead, or not directly overhead, take that back, being at its highest point at 120 degrees. Okay, and this is, ask you here, we have this controlling meridian, or again, standard means the same thing, 120 degrees west. But what is the exact longitude to the degree of Lancaster, California, right? I want you to be looking and thinking about, what does that mean when our watches say noon, but where is the sun in the sky? Is it at its highest point here in Lancaster? What's the difference? The second question in here, since the Earth rotates to the east, will the sun in Lancaster reach its highest point in its daily arc before or after our watches show 12 noon, right? 12 p.m. With any of this stuff, if you are getting stuck with it, use props. I think I say that in the lecture class too. Like if you have a globe, good. That means you're a good human being. Because everyone should just have a globe at home. They're fantastic. But if you don't, use whatever you got. Use a basketball. Use something round. It doesn't even have to be round. We can pretend. Use a box. Just use, something. But try to mimic this idea of, the Earth rotating to the east, and you can have your hand over here can be the sun. You can rotate the globe and see what's going on, right? And figure out where is 120 degrees west, where is Lancaster, that kind of stuff. All right, do the best you can with that. But this will be a good reference down the road. Okay? Now, as you continue on, this is continuing this idea of, the Lancaster thing from those previous ones. Let's see. This is going to get into the whole calculating one's longitude. So you're going to listen to that geodesy stuff, but read through. It should hopefully make sense, okay, as you're going through. And if not, shoot me an email or whatever. But then once you get through that, once you're now a master of calculating your longitude and your latitude, you're going to have these 4 different scenarios. Okay, so like on your way to a much needed vacation in Hawaii, your small plane runs out of gas. Blah, 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 blah. So you're going to go through here. You're going to be, going through this scenario. You're going to get just enough information to figure out your latitude and your longitude. Now, this first one, you can, read through all of this stuff. You have the image to get that solar angle to do all that, and you're going to be answering this stuff as you're working through. Right? So this one's pretty straightforward because it has you work through it and practice it. Right? Geographic situation number 2, not going to be that easy. Right? 3, not that easy. 4, not that easy. And some of these are shorter than others and longer than others, but they all, I swear, have everything you need to calculate your latitude and your longitude. And so if you don't see an image like this, there's got to be something else in the description here, in all this, data that is being thrown your way to help you calculate where the sun is in the sky, right? And therefore, what your latitude is. So read through carefully. Okay, and then some of these other questions too, it's, assume like here, in what compass direction should you head if you want to get to Singapore? All right, we're not in a lab right now, so we don't have maps and globes and all that stuff all around. Do the best you can. Like when you figure out your latitude and longitude coordinates, you can plug them in to Google if that works, or pull up a world map on the computer, see if you can figure out roughly where you are, right? And then you should be able to, hopefully it'll be clear if you're doing this stuff, what country are you closest to? That should be pretty obvious. And then you should be able to figure out what direction is Singapore, right? Also pay attention to, in this stuff, like in the lecture class, one last thing about the differences here. In the lecture class, I'm only using Greenwich time and the prime meridian when I'm getting into how we calculate our longitude. In here, we're dealing with, like this first one, we're dealing with Hawaii and Pacific Standard Time and all of that stuff. So like be aware of that, right? You're calculating how many degrees longitude you've traveled, but you're not starting at 0. Here you'd be starting at 120 degrees, right? Because that's the controlling or standard meridian, right? So imagine you're flying from California. You're not flying from Greenwich, England. Think of it that way, okay? And I think we have it in here so you Yeah, longitude of the controlling meridian. So hopefully you catch that as you're going through. But you're going to be traveling around, cruising around. You're in Florida, um, Perth, Australia, all of that stuff. So just pay attention to that, to these details, and also refer back here, right? Like, do you know where Perth is in Australia? Americans? Do you? Of course not. So look that up. Again, Google the thing. Look on Google Maps, whatever. But your controlling meridian is either going to be 120, 135, or 150 degrees east. Okay, and that direction will also be key. So take your time with this. Read through. Feel free to work together as long as your answers are your own and you actually get this stuff. But take the time to work through it, right? Don't give up. It should be quite doable if you just, plow through and listen to those lectures I referenced and all that other stuff. And the good news, yeah, this might be a pain to get through, but once you're done with it and you've completed it, you're going to be like, yeah, I am amazing, right? This is some Indiana Jones stuff right here. This is going to be fantastic. So enjoy, have fun, and I'll talk to you later, geographers. Best of luck.